Standing on these sun-baked shores, listening to the waves crash, and tasting the salt in the air, you would swear you were at the edge of the open ocean. But geography is playing a trick on you. This cross-section illustrates exactly what is happening. The surface of the water here, and the massive landmass surrounding it, actually rest nearly 100 feet below the global sea level. You are standing inside one of the lowest depressions on the planet. Because of this steep drop, cutting a channel to connect this basin to the nearby Black Sea would be an absolute disaster. Oceanic waters would rush down into the depression, permanently flooding thousands of square miles of coastal territory across 5 nations. This 100-foot drop marks a sharp boundary between the global ocean system and a body of water that operates under its own set of rules. To understand why it acts so strangely, we have to look at a concept called an endorheic basin. This is a completely closed drainage loop, a giant geographic sink where water flows in but never naturally flows out to the open sea. The lifeblood keeping this sink filled is a massive network of over 130 rivers. As we see here, none is more vital than Russia's mighty Volga River, pumping about 80% of the fresh water into the system. With absolutely no rivers flowing out, the water only has one physical exit strategy: intense, continuous evaporation under the harsh Central Asian sun. Every fluctuation in water level and every chemical change relies entirely on the fragile balance between what the rivers bring in and what the sun bakes away. It's an escapable trap, one that forced millions of years of bizarre biological and economic mutations. 30 million years ago, a massive body of water called the Paratethys Sea stretched from the modern Alps across Central Asia. But as tectonic plates collided, the land buckled upward, forging towering mountain ranges that sliced the ocean apart and sealed the Caspian inland. This map shows how the isolated water chemistry warped. In the shallow north, the Volga dumps so much fresh water that it's practically fresh enough to freeze over in winter. But travel south, and the water becomes trapped in violently evaporating hypersaline bowls. The marine life locked inside had to adapt to these wild extremes. The Caspian seal is one of the only seal species on Earth that lives its entire life isolated in icy, brackish inland waters. Sharing these waters is the beluga sturgeon, a prehistoric survivor that grows to the size of a small car and lives for over a century. Cut off from the global gene pool, the basin became a strict evolutionary laboratory. These highly specialized animals prove that life can morph and thrive, even in total permanent isolation. That isolation eventually confronted human merchants. For centuries, caravans moving goods from China to Europe reached these shores and faced a choice: trek overland through the harsh northern steppes, or turn the enclosed sea into a bustling maritime highway to connect the economies of the East and West. But the real prize was underground. Millions of years of trapped organic matter decayed in this closed system, birthing the global petroleum industry right along the shores of Azerbaijan. By 1900, Baku produced more than half the world's crude oil. As demand exploded, engineers pushed directly off the shoreline into the shallow waters, eventually constructing sprawling piers and the world's first true offshore drilling platforms. Today, extracting that wealth requires extreme engineering. In the freezing northern waters off Kazakhstan, companies have constructed massive artificial islands specifically to shield their drilling equipment from crushing winter ice flows. Millions of years of geological quarantine trapped tens of billions of barrels of oil and gas within this single basin. This concentration of resources transformed the landlocked region into an industrial frontier, dictating the financial future of 5 different nations. For most of the 20th century, managing that wealth was highly organized. Just 2 sovereign powers, the Soviet Union and Iran, controlled the entire coastline, dictating navigation and fishing rights through simple, clear bilateral treaties. That simplicity vanished in 1991. The collapse of the Soviet Union acted as a geopolitical earthquake, immediately fracturing the coastline and giving birth to 3 newly independent nations: Kazakhstan, Turkmenistan, and Azerbaijan. This map demonstrates the core of the 20-year legal war over the oil. Iran argued the basin was a lake, dividing the waters equally into 20% pie slices. But the newly formed states argued it was a sea. If recognized as a sea, territorial rights would be dictated by coastline length, giving nations with longer shores a massive legal advantage. The deadlock lasted until 2018, when the leaders compromised by legally classifying it as neither. They built a Frankenstein framework, where surface waters are treated like a sea for navigation, but the seabed is carved up through complex neighbor-to-neighbor agreements. Because there are no external borders and no outlets to the open ocean, these 5 nations are locked in a room together. An oil spill, an overfishing crisis, or a military decision in one country's sector immediately becomes a crisis for the shores of the other 4. And right now, they are collectively facing a crisis that threatens the entire basin. Because this is a closed loop, the system still obeys one strict ancient rule: water can only leave through evaporation. Rising global temperatures are baking the Central Asian landscape, supercharging that evaporation to extreme new levels. At the exact same time, humans are turning off the faucet. The mighty Volga River is suffering from reduced rainfall, while intensive agriculture and massive hydroelectric dams upstream throttle the remaining fresh water before it ever reaches the coast. The water level is dropping by several centimeters every single year. Boats are being left stranded in thick mud, and bustling coastal towns now sit miles away from the rapidly retreating shore. The deep-time geological isolation is what gave this basin its prehistoric marine life and unimaginable fossil fuel wealth. But that exact same isolation means it has no natural way to replenish itself, leaving the largest inland body of water on Earth dangerously close to becoming a barren desert.